I would like to start by thanking PACTS for the opportunity to share the development of our national framework for light electric vehicles. And before I explain how we in the Netherlands integrated light electric vehicles, LEVs, into our infrastructure, I would like to take a bit of time to explain what we consider light electric vehicles and to explain the new LEV framework we are working on. In the slide, you can see, among others, the most common LEVs we see on our roads. We have the vehicles for personal use, like the e-bike and the e-scooter, the micromobility vehicles. But LEVs also include electric vehicles for cargo delivery or for the transportation of children. And LEVs can either be pedal assisted or throttle operated. And the cargo bikes can, or the transportation of children can be 2 or 3 children, but we also have LEVs that can transport 8 children at a time. And these vehicles are popular among children daycare companies. We also see some electric skateboards or motor wheels on our roads, but these vehicles are currently prohibited because these vehicles lack a conventional steering mechanism. Due to the rapid development in LEVs, we are in a bit of a strange situation in which the same regulations apply for vehicles with completely different characteristics. So, for example, shown by the light blue rectangle in the slide, the same rules apply to the e-scooter and to the electric cargo bikes that can transport 8 children. We also have the opposite situation, in which different regulations apply to vehicles with more or less the same characteristics. So, for example, shown by the dark blue or by the black rectangle in the slide, actually different regulations apply to the 2 cargo bikes transporting 8 children. Well, after a serious accident in the Netherlands, the Dutch Safety Board observed the need for a better targeted regulation framework for the various types of LEV. One recommendation was that the new framework should not only cover the new micromobility devices, but that it should also cover e-bikes and cargo bikes, hence our focus on LEVs. Because of the fact that there was no European framework yet, we started with the development of a new national LEV framework in 2019. The main goals of the frameworks are the following. Well, first of all, road safety should come first. And to accomplish this, the framework should ensure vehicles are technically safe and can be safely used within existing infrastructure and with existing road users. This is also the topic of today's presentation. And the third bullet is also related to today's topic. The technical requirements should ensure all different types of LEVs move more or less similarly, with approximately the same speed and acceleration as the other road users they share the road with, so they can be safely used within existing infrastructure. And finally, also important, the rules and regulations should be predictable, proportional, and unambiguous for consumers, manufacturers, and road management authorities. Well, how did we come to this national framework? Well, we worked together with the RDW, the Netherlands Vehicle Authority, and SWOF, our National Institute for Road Safety Research. We also spoke to many stakeholders, conducted interviews, and held webinars with them. We also commissioned various studies, and we have listed a few notable ones here for today's presentation. Rijkswaterstaat, the executive agency of our ministry, they looked into the risks of integrating LEVs with fast and slow traffic, so with bicycles and motor vehicles. And Delft University of Technology determined the requirements for the maximum power threshold. These studies are publicly accessible, but unfortunately they are all in Dutch. However, if you're still interested, please let me know and I can share the link. Well, the outline of this framework was finalized by the end of 2021. And in the next slide, I will show you this new framework. Well, as we saw in the title slide, there's a huge variation in vehicle mass among LEV. We therefore decided to make 2 different categories based on vehicle or curb mass. And then within these 2 categories, we made a further division for reasons related to authorization and surveillance or to specify technical requirements. I will not go into detail about this today as it's outside the scope and due to time constraints. In total, the new LEV framework is divided into 4 categories. In category 1A, you see the normal e-packs, e-bikes, and the light carrier cargo bikes for the so-called family use, transporting your own children or light cargo. In category 1B, you will see all types of personal mobility devices, which are light and not an e-pack, most commonly the e-scooter. In category 2 are the heavier vehicles, and we further distinguish cargo bikes and carrier bikes for passenger transport. In the rest of the presentation, I will call them the heavier cargo bikes. Well, for all these 4 categories, we developed specific requirements with respect to technical requirements for the vehicle, authorization and surveillance, and requirements for road use. All 3 are essential to safely integrate LEVs in our existing infrastructure. Well, let's first have a look at the technical requirements, because when deciding what is the safest way to mix LEVs with other road uses, the speed, dimension, and the mass of the vehicle is important. These are defined in the technical requirements and can be specified per category. As mentioned, the main differentiation between the categories is in the total maximum mass of the vehicle. All categories have the same maximum speed of 25 km/h, which is similar to that of an e-bike. So there's no variation in maximum speed between the categories. The maximum dimensions of the vehicles are also more or less the same, only vehicles in category 1B are slightly smaller. The maximum width of 1 meter for the other categories is a reduction compared to the current regulations. The 1 meter is based on a guideline which prescribes that a separate bi-direction bicycle path, of which we have a lot in the Netherlands, should be at least 2 meters wide. The 1 meter restriction would ensure that on those bicycle paths, 2 cargo bikes can pass each other. Note that the 1 meter and this complete framework is a proposal and still has to be approved by Parliament. However, because we already spoke to a lot of stakeholders in the process, we know that most stakeholders agree with most aspects of the framework. The only question that still has to be decided is whether LEVs should use the cycling infrastructure or share the road with motor vehicles. This is just the topic of today's presentation, so unfortunately I cannot share the outcome yet, but I can share the current process, the current situation, different suggestions we received, and the arguments we have heard. Well, the discussion is also quite limited because of the smaller size and mass of the vehicles, almost all stakeholders agreed that the bicycle path or lane was the best place for e-bikes and e-scooters, so for LEV category 1A and 1B. There are different views about category 2, the heavier cargo bikes, because these are wider and heavier. However, also for these vehicles, we and also most stakeholders still have a preference for the bicycle path. We have a preference for the bicycle path because studies estimated that only up to speeds of 30 km/h is it safe to mix vehicles with a large difference in mass. For roads with a higher speed limit, for example 50 km/h, studies estimated the risk for the heavier cargo bikes among motor vehicles to be higher than the risk of other bike path users if they have to share the bike path with heavy cargo bikes. Hence, we also have a preference that the heavier cargo bikes, LEV category 2, use the bicycle path or bike lane on roads with a speed limit of 50 km/h or higher. Again, almost all stakeholders agree, especially for roads outside residential areas. There is a discussion with stakeholders about 30 km/h roads. In the Netherlands, some of the 30 km/h roads within residential areas have a separate bike path. And in some cities, these bike paths are very crowded and space is limited. The wider cargo bikes would require a lot of this valuable space. As mentioned, vehicles with a large difference in mass can be safely mixed at this speed. And one suggestion was that for these roads and these cities, the heavier cargo bikes would share the road with motor vehicles and not use the bicycle path. It's a good suggestion, especially for locations where the bicycle path is crowded, but there are also some counter-arguments to this proposal. A counter-argument to this would be that speed measurements show that most motor vehicles exceed the 30 km/h speed limit on these roads. Another counter-argument is that currently the number of 30 km/h roads with separate bike paths is small, and also the number of heavy cargo bikes is estimated to be small. It would make it harder for consumers with a heavier cargo bike to know when and where he or she should ride. It would also make enforcement more difficult because currently the heavier cargo bikes of LEV category 2 cannot be visually distinguished from the lighter cargo bikes of LEV category 1A. Hence, our preference is that the heavier cargo bikes also use the bike path. And we also designed the other requirements with this in mind. One of the other requirements, technical requirements that I would like to highlight for today's presentation concerns the maximum power. We set this requirement to ensure all LEVs move more or less similar to bicycle path, as we have a preference to use the cycling infrastructure. With approximately the same speed and acceleration as the bicycle, we hope to avoid conflicts and ensure LEVs can be safely used within the existing cycling infrastructure. As the mass has a huge influence on acceleration, different maximum power thresholds were defined per category, as can be seen in the slide. A final requirement that I would like to highlight with respect to integrating LEVs into our existing cycling infrastructure is that the type approval process of e-scooters and the heavier cargo bikes includes a driving test. This driving test includes an emergency stop and an evasive maneuver, but it also includes riding over different type of infrastructure and obstacles a cyclist might encounter. For example, different road surfaces and riding up and down small obstacles such as a speed bump, raised ledges, entrance constructions, or the sidewalk. I believe this driving test neatly ensures, without defining a whole list of technical requirements, that LEVs can cope with existing cycling infrastructure in critical situations. Together, all the highlighted requirements should ensure a safe integration of LEVs in our existing cycling infrastructure. As mentioned before, the outline of the framework was finalized by the end of 2021. We are currently preparing legislation and further developing the framework. Our ambition is to submit our proposal to Parliament in the first quarter of 2024. However, the ultimate aim is to arrive at an international framework for LEVs in order to prevent a patchwork of different rules developing in different countries. If others have the same goal, I would love to get in contact and talk further. I added my contact details on the last slide, together with an overview of the team, my colleagues, with whom we are working on this topic. If you have any further questions, please do not hesitate to ask us. And thank you very much for listening.